of alcohols. उसके अंडर फर्स्ट इज फिजिकल प्रॉपर्टीज ऑफ अल्कोहल्स. इन फिजिकल प्रॉपर्टीज अपन वैसे ऑलरेडी कर ही चुके हैं. फर्स्ट इज स्टेट. स्टेट सानू पता है कि जो लोअर मेंबर्स हैं दे आर कलरलेस लिक्विड्स, हायर मेंबर्स आर solids, and they are odorless. And the next is main is boiling point. We already know alcohols have hydrogen bonding, therefore they have higher boiling points. But question is, why alcohols have higher boiling points than haloalkanes? As haloalkanes are also polar, but in alcohols hydrogen bonding is present, therefore they have higher boiling points. And then is the hydrogen bonding can be shown as ROH, and then with second molecule it forms hydrogen bonding, and these hydrogen bondings are stronger than dipolar bonds. So alcohols have higher boiling points than haloalkanes. Then next is solubility. In solubility, alcohols are soluble. Why? These are due to hydrogen bonding. In hydrogen bonding, we have to show hydrogen bonding of alcohols with water. That is HOH. It is HOH. Alcohol with water form hydrogen bonding. Therefore, they are soluble in water. And thus, lower members have stronger hydrogen bonding because alkyl group is smaller. So they have higher solubility than higher members. Higher members means in which alkyl chain increases. As alkyl chain increases, the solubility decreases. And then is chemical properties. In chemical properties, we divide these properties of alcohols in three parts. First is reactions in which CH bond breaks. OH bond breaks. OH bond breaks means in which alcohols show acidic character. And second, reactions in which carbon oxygen bond breaks. That is, OH is replaced by some other group. And third, the reactions in which both alkyl and hydroxyl group are involved. So, we categorize the reactions of alcohols in three. First is reactions in which OH bond breaks, that is, which shows acidic character of alcohols. Second, involving carbon oxygen bond cleavage. And third is reactions involving both alkyl and hydroxyl group. So, we start with reactions involving cleavage of OH group, that is reactions in which acidic character is shown. First is reaction in metals. Reaction in metals, that is like sodium. When sodium reacts with alcohols, hydrogen gas is released and RONA forms. A must be small, that is R capital, O capital, N capital, A is small, and it is sodium alkoxide. And then if we take a particular example like ethanol with sodium, it gives hydrogen gas and sodium ethoxide. Similarly, if we treat alcohol with magnesium, then RO twice Mg is formed plus hydrogen gas is released. As valency of magnesium is 2, therefore 2 alkoxide groups are attached. And similarly, if we treat alcohols with aluminium, then RO thrice Al will be formed with the release of hydrogen gas because valency of aluminium is 3. So, these active metals react with alcohols to get hydrogen gas. That is, in these all three reactions, hydrogen gas is released and As we have already done, out of alcohols and water, which is more acidic? Which will be more acidic? Water is more acidic. This we have already done. This already we have. We can explain this with these formulas. ROH, that is alcohol. HOH is water. In this alcohol, R is electron releasing group. Electron releasing group increases the electron density in oxygen, and therefore oxygen hydrogen bond breaks with difficulty because oxygen is already electron rich, therefore it has no need to attract shared pair of electrons from hydrogen, so H positive release will be difficult. While in water, there is no electron releasing or withdrawing group attached to oxygen, so H positive will be released easily as compared to alcohols. So, as comparison to alcohols, water are more acidic in nature. And similarly, if we compare primary, secondary and tertiary alcohols, which will be more acidic? Out of these, primary will be more acidic,
Primary.
then secondary, then tertiary. And if we take methyl alcohol will be most acidic, because in all these, in primary, there's only one alkyl group is present. In secondary, two alkyl groups are present. In tertiary, three alkyl groups are present. These alkyl groups increases the electron density on carbon, which in turn increases electron density on oxygen. Therefore, oxygen has no tendency to attract electrons towards itself from hydrogen. Therefore, H positive release will be difficult. So, lesser the number of alkyl groups attached to carbon, greater will be the acidic strength. So, in methyl alcohol, no alkyl group is attached, so it is most acidic, then primary, then secondary, then tertiary. So, order is 1 degree, most acidic, then 2 degree, then 3 degree. And then second, in reactions in which only H is replaced as reaction with Grignard reagent RMgX. In this, when Grignard reagent is treated with alcohol, H of alcohol and R of Grignard reagent forms alkane RH, and OR is attached to magnesium, that is MgORX. That is alkoxide magnesium halide, and alkane is formed. So if we take a particular example, that is replacing R by C2H5 ethyl group, then we get methane as a final alkane and side product. Similarly, if we treat alcohols with metal hydrides, that is sodium hydride, let us say sodium hydride, then in this also hydrogen gas is replaced and alkoxides are formed. If it is ethanol, then sodium ethoxide plus hydrogen gas is formed. And similarly, if we treat alcohols with carboxylic acid, in that case also hydrogen of alcohol is replaced. Only hydrogen is replaced. So it is also a reaction in which cleavage of OH bond takes place, and if alcohols are treated with carboxylic acids, in the presence of acid, we get ester plus water. As we get ester, therefore this reaction is called esterification reaction. So, alcohols with carboxylic acids in the presence of acid gives esters, and this reaction is called esterification reaction. This reaction we have already done in first two also. Similarly, if alcohols, suppose ethyl alcohol with ethanoic acid is treated, then CH3COC2H3 plus water is formed. That is OCH2CH3 comes from ethanol, and CH3COO comes from ethanoic acid. The final product is ethyl ethanoate. The alkyl group attached to this product is CH2CH3, so it is ethyl. Ethyl will be taken as a prefix, ethyl, and two carbons are present in the word root, so it is ethyl ethanoate as ester group is present. So this reaction is called esterification reaction. In this, if we take instead of acid dry HCl gas, if dry HCl gas is taken instead of acid, generally HCl, but if it is dry HCl, then it is Fischer-Svyer esterification reaction. It's important. It can be asked in naming reactions. What is esterification reaction or what is Fischer-Svyer esterification reaction? In the second reaction, we use specially dry HCl gas. In earlier, we use acid, and it is generally H2SO4, sulfuric acid. Okay. Then is reaction with acid chlorides or acid anhydrides. As we already know, if alcohol is treated with carboxylic acid or any of the derivatives of carboxylic acid, then always ester is formed. So similarly, if it is acid chloride with alcohol, we get ester plus HCl. And similarly, if we take alcohol with acetic anhydride in the presence of pyridine, then also ester is formed and second side product is carboxylic acid. So alcohols with carboxylic acids, with acid chlorides, with acetic anhydrides, always esters are found as a main product. So these are the 5 reactions in which only H is replaced. That is, first is reaction with active metals, second is with Grignard reagent, third is with carboxylic acids, fourth is with acid chlorides or acid anhydrides, and fifth is with metal hydrides. So these 5 reactions are in which only oxygen hydrogen bond is cleaved, and these reactions show the acidic nature of alcohols. So next is reactions in which OH bond breaks, means CO bond breaks, and in this tertiary are the more reactive. In the first, in which OH bond breaks, in that case primary were the most reactive, then first primary, then secondary, then tertiary. And in these in which carbon oxygen bond breaks, tertiary are most reactive, then secondary, then primary. Because in tertiary we have 3 alkyl groups. These alkyl groups increases the electron density on the carbon atom. So carbon becomes slightly negatively charged. Oxygen is also electronegative, it's also negative charge. So these have repulsion in between them, and this bond breaks easily. But in secondary, only 2 alkyl groups are present. So the repulsion between carbon and oxygen decreases as compared to tertiary. And in primary, only 1 alkyl group is present. So repulsion between carbon and oxygen is still lower. So in reactions in which carbon oxygen bond breaks, tertiary are most reactive, then secondary, then primary. And then comes the reactions. First is reaction with hydrogen halides, HX. If we talk about halogen halides, that is HI, HBr and HCl, out of these, which is more reactive? More reactive is HI, and then HBr, then HCl. Why? Because in HI, or say as we move down the group, that is from top ClBrI, as we move down the group, the size increases. As size increases, the bond length increases. So greater the bond length, weaker it will be, or it will be more reactive. So HI is more reactive because in this size of iodine is largest and the bond length of HI is greater and it can be easily broken. So when these reagents, that these hydrogen halides react with alcohol. In this case, as the reactivity difference is there, so these react with alcohols at different conditions. Different conditions are required. First is reaction with HCl. HCl is least reactive. HCl is least reactive. So in this case, anhydrous zinc chloride is used. And in the presence of anhydrous zinc chloride, only OH group of alcohol is replaced with Cl and water is formed. And taking a particular example, that is 2-propanol in this, when it is treated with HCl in the presence of anhydrous zinc chloride, it gives, that is OH is replaced with Cl and water is formed as a side product. Similarly, in tertiary, we get same, OH is replaced with Cl. So what is the difference between these three reactions? First is of primary alcohol, second is of secondary alcohol, third is of tertiary alcohol. What is the difference between them? In these reactions, tertiary is most reactive. So tertiary alcohol reacts at room temperature and secondary requires less heat and primary requires more heat to react with halogen halogen halide. So HCl reacts with alcohols in the presence of some catalyst, say anhydrous zinc chloride. But when alcohols are treated with HCl, then the reaction is called GURUSAR method. That is, this method of preparation of halides from alcohols in the presence of HCl gas in the presence of anhydrous zinc chloride is called GURUSAR method. So next is reaction with HBr. When alcohols are treated with HBr, in this same, OH is replaced with Br. But difference is HBr is more reactive than HCl. Therefore, only few drops of concentrated sulfuric acid is used. In the presence of concentrated sulfuric acid, few drops, alcohols with HBr gives bromoalkane and water. And in this, the mechanism is, first, alcohols react with acid, gives protonated alcohol, that is H gets attached to oxygen through lone pair and positive charge is now present on oxygen. And then with Br negative of HBr, it gives, this is removed as a water and Br negative gets attached to ethane, that is C2H5Br, bromoethane is formed. And now with HI, as we already know, HI is most reactive, so no reagent is required, only we can prepare hydroalkanes or alcohols react with HI just at warming or just refluxing this mixture and we get alkyl halide, that is hydroalkane. So when we treat alcohols with halogen acids with HI, HB or HCl, as HCl is least reactive, so in this phosphorus halides that are PCl5, PCl3, PBr3, these react with alcohols. Again, OH of alcohol is replaced with halogen. If it is PCl5, then we get alkyl halide with plus POCl3 plus HCl. POCl3, that is phosphorus oxychloride. And if it treats with PCl3, then we get H3PO3 phosphorus acid. And if we treat with PBr3 or PI3 with alcohol, then bromoalkane and hydroalkanes are formed and same phosphoric acid is formed as a side product. But in this we have written P plus bromine or P plus iodine on the arrow. It means PBr3 or PI3 are not used directly. They are prepared within the reaction. They are used in situ. That is, phosphorus with bromine is added and PBr3 is formed within the reaction and it reacts with alcohol to give this product. And similarly, P plus I2. That is, PCl5, PCl3 are stable. We can use them directly PBr3 or PI3 are used indirectly, that is by using mixture of red phosphorus and bromine or phosphorus plus iodine as the reagents. And the next is reaction with thionyl chloride. Alcohols with thionyl chloride gives alkyl halide with sulfur dioxide plus HCl. In this, alcohol with SOCl2 reacts and OH is again replaced with halogen, that is Cl plus SO2 plus HCl is formed. And in this reaction, we get side products as gases. So this reaction is preferred as compared to earlier ones, that is reaction with halogen acids or reaction with phosphorus halides. In this, side products are gases. So these haloalkanes are more easily, conveniently extracted. So this method is preferred over first two. And then fourth is reaction with ammonia. If alcohols react with ammonia, we get amines. That is 1 degree, 2 degree, 3 degree amines are formed. Alcohol with ammonia gives OH and H of ammonia is removed as water and NH2 gets attached to carbon. That is, if primary are treated alcohols, then we get RNH R plus water. If primary amines are treated, if ammonia is treated, we get amines. Amines, that is primary amines are treated with alcohols, then we get secondary amines. If secondary amines will be treated with alcohols, then we will get tertiary amines and so on. Example is C2H5OH with methylamine gives C2H5NHCH3. NHCH3 means it is N substituted. So it is N-methyl ethanamine, as H of amine is replaced with methyl group. It is NH2, but hydrogen of amine is replaced with methyl, so it is N-methyl. Methyl attached to nitrogen atom. N-methyl ethanamine. And similarly, so if these four reactions are the reactions in which only OH is replaced, that is, first is reaction with halogen acids, second is reaction with phosphorus halides, and third is reaction with thionyl chloride, and fourth is reaction with ammonia. These are the four reactions in which carbon-oxygen bond breaks, or say OH gets replaced with some other group. And the next will be the reactions in which and similarly alcohol with secondary amine gives tertiary amine and water. So these are the reactions of group in which OH group is replaced. So with this, two types of reactions, that is reaction in which carbon oxygen hydrogen bond breaks, and second in which carbon oxygen bond breaks is complete. Then next, in the next lecture, we will start with reactions in which both alkyl and hydroxyl groups are involved. हाँ जी बेटे, समझ आ गया थे तक? हेलो,
यस मैम.
स्क्रीन विजिबल सी?
यस मैम. हाँ जी मैम. यस मैम.
Yes, ma'am. Yes, ma'am.
बोलो बेटा, स्क्रीन विजिबल सी?
यस मैम.